Everyone, thank you for joining the Isaac Sim office hours today. I'm Rishabh, an engineer with the Jetson product team, and I focus a lot on robotic simulation. So today I'm hoping to go through the new features which are a part of the release for Isaac Sim, which took place a couple of weeks ago. And I'll also be taking a deeper dive into some of the ROS portions given the changes which we've had for this release. So uh, excited for this. And if you have any questions, please post them in the chat. I'll try my best to answer them and we can get started. I'll be looking at the release notes and we'll walk through a couple of important new things which are out here. And I'll try to explain even while I'm opening up IsaacSim and showing you the sample so that you can understand what's happening. But again, if you have any questions or if you have any specific concerns, please post them in the chat right here. And we're active on the forums as well. We can't answer them right here. I'll try my best to make sure we answer them in the forums and we'll get back to you. So with that, let me start sharing my screen. Um, yep. So the page I'm looking at right now is the Isaac Sim official documentation page, and we're at the release notes section. So the 2023 release notes for the version of Isaac Sim just released a couple of weeks ago. So we've got a lot of changes, specifically around the raw side, around manipulation, around replicator for synthetic data generation, and even some general stuff regarding how URDF to USD exporters and importers, they've been workflows for them as well. So I'll be walking through that too. You can see the chat is pretty active. Let me see this. Where we posted a lot of questions in the Isaacson Discord. Hi, Savet. So, are the questions which you've posted relevant to the 2023 discussion we're having right now, or are they general Isaacson questions? And have you also posted them on the forums? Uh, I'll let you back. I'll let you answer that in the comments, but I'll continue with the stuff which we have planned for now. So, okay, the first thing which I'm planning to show you is the USD to URDF exporter to actually show what that is. Let me start Isaac Sim. So I have a terminal open right here, and I'm going to start Isaac Sim. And as you know already that the previous versions of Isaac Sim, even the 2022 ones and the ones before that, had a URDF importer. So what that allowed you to do is you've had your entire robot configuration defined as the URDF format, and you can bring that into Isaac Sim so that it can be run as a USD. And what that basically does, it passes through your whole document, it goes through the links, the joins, and all that stuff, and make sure the corresponding stuff is set up correctly in Isaac Sim so that the USD, which is then created with the meshes, works correctly as expected with the physics. So basically, it's just weird stuff does not happen when you hit play, like the robot does not explode because physics was incorrect or stuff like that. So we have IsaacSim 2023 open right here, and I'm going to start up the corresponding extension for the USD to URDF importer. So let me look for that. So this is the extension which is a part of the new release, which I just talked about right here. It's the USD to URDF exporter, and what that allows you to do is once you've set up and maybe run through your entire workflow for a robot in USD, you can now export it to URDF. So let me just go ahead and enable this extension. So I've enabled it, and I can see right here that I've got a menu item which has popped up, which allows me to then use this particular extension. So I'll open up the sample for here, and it's asking for a USD path. So let me go ahead and look for a USD path. We can look for an IsaacSim robot asset already existing. And we have a bunch of robots as well, which have come out with the new release. But I think most of y'all would be familiar with TurtleBot. So let me go ahead and open up a TurtleBot sample right here. So this is the totalbot USD which we have, and I'm going to just export it. So let me put it here. I can put it as it's the totalbot burger. So let me make sure I name it correctly. Dot and let me go ahead and do that. And I'll also open up the terminal so you can see what happens when I actually hit export and the log is generated. So this is fine. It's not an error. It's giving me the information right here down that the input file and the corresponding output file which is generated. So the USD which you provided as the input and the output as the corresponding URDF which was generated. So let's go ahead and look at the URDF right here. Drag and drop this here. Go in my downloads folder and look for. Okay, this is the file which we have. Let me open it at VS So this is the URDF which has been generated from our tool, which was the USB to URDF exporter. So it has all the joins, all the corresponding links with their inertial properties, their visual properties, geometry properties, collision properties. And just for reference, on the right side here on my screen, I've also opened up the original Turtlebot URDF file, and you'll find that the stuff right here has the direct correspondence with the robot related description format right here. So this is how you can use the URDF file from once you've exported it from the USD format from IsaacSim, and that's the basic workflow of just selecting your file and making sure that things are aligned correctly. And the other option which you also have with this particular tool is you can select the mesh directory. And what that is basically that we know that meshes are also part of how the URDF parses files and actually stores information, even for colliders and for various other robot attributes. So those meshes also are correspondingly generated right here, and that is optional in terms of the advanced features which you can use. So this was about the USD to URDF exporter, which came out with the new release for IsaacSim, and we can take a look at the release notes again. I'm going to quickly jump over to the chat and see if we have any questions. Okay. I can see someone saying something about ROS navigation. I can briefly cover that too during the live stream today, where I'll talk about how it is set up. And if you are seeing a crash, I would recommend you post it on the forums. You can also tag me. I'll try to help out there, but I'll give you a brief overview of how the scene is set up and how you can run ROS navigation. Okay, so let me get back to the next things which we have here. So there are a lot of updates for the ROS section in particular, with the users now being able to source their workspace and Isaac Sim being updated to Python 3.10. So there are changes, and that is something I'll be diving into deeper later during our session today. I'll just briefly go through all the other aspects which I wanted to talk about before getting into the ROS side of things. So there are a lot of new robots for you to play around with. We've got new manipulators, we've got new AMR. So let me show you quickly where you can find them. So let's go ahead and you can go under create and you'll go Isaac, you'll get robots, and you'll see that we have now a lot of robots added into our collection, and they've been sorted according to manipulators, quadrupeds, quadcopters, wheel robots, and all the others. So the newer ones which are here, as you can see, there's a Fanuc robot right here. And so the fun things about these robots is obviously all the joints, all the physics, all the colliders have already been set up for you. So you don't need to worry about any of that. You can straight away use the Python API to maybe control the robot itself through the joint API. Or if you want to set up ROS with Move It, maybe for manipulators, we've got tutorials and workaround guides for how to do that too. So we've got various robots for you to play around with, and let me open maybe one of the quadrupeds as well. Uh, Sorry about that. Was the wrong path right there. Uh, okay, so yeah, we also have quadrupeds right here. You can, for people who are not very familiar with Isaac Sim, uh, let's add a stage such that a flat grid. This looks okay right here. And my quadruped right now seems to be in the air, but I think that should be okay. I'm going to hit play and you should see what happens. So, okay, so it's probably the joints have been set up in such a way that you saw when you hit play and physics actually started stepping through the simulation. That's the behavior you get, and you can obviously control this programmatically through the joint API through Python. And we can also actually go and take a look at the joints and the other things which you want. So you'll find all the corresponding joints for your robot set up here. So it's got the hip joint, it's got the calf joints right here, and you can go ahead and play around with it. But there are a lot of new robots in Isaac Sim which you can actually take a look at, and obviously we also have ways of getting your own robot into Isaac Sim. One way which we already talked about is the URDF importer, where if you already have a URDF, you can get it into USD. We also have 3D CAD model importers, so those are other formats you can use to actually get the representation of your robot into Isaac Sim. With other formats, the only small issue which you would face is you would need to set up the physics yourself. So there are guides on terms of how to set up physics where you identify what sort of joints, bodies need to behave in a certain way, and that is how you can rig it up so that it can behave correctly. So I can quickly show you what is meant by that. Let me open up that corresponding tutorial. It's more of an advanced tutorial where it's going to be about how you can rig up your robot. Um, yep. We also have changed the interface for the entire documentation to make sure that things are easier to find for first time users. Let me actually go ahead and just Google that. Yep, right here. So this is the tutorial which I was talking about in terms of rigging robots. So this talks about how if you have an asset which does not have any physics defined correctly for it, so it's just the visual meshes. So how you need to structure your asset such that the body and maybe the wheels they move together. You define the joints such that it may be a revolute joint if it's a wheel, it may be a prismatic joint if it's a linear sort of motion between two relative bodies. So that is how you can specify all these parameters right here, and it's a step-by-step instruction based workflow where you start with an unrigged asset and towards the end where you'll actually be able to have a completely rigged forklift which you can then maybe hook up to ROS or connect with your own controller to actually make sure that it performs in a certain way. So that is how you can actually work with getting robots into Isaac Sim. And in terms of sensors, we also have new sensors. Let me open up a new stage and show you that right here too. We have new sensors so the sensors can also be found again right here under the Isaac section. We have the physics lidar, which was already a part of Isaac since many releases right now, and the newer version which came out last year as well, the RTX slider, which has now become the default for many of the assets which we already have. But for RGBD sensors, we've added real sense and the Orbex sensors, which you can look at. Let me open them up right here. Okay, there is a real sense. Apparently, it is very small, so that's why I couldn't see it. Let me add a stage again in the background so we can understand what it looks like. Oops, not the stage. So this is a camera right here, the real sense camera, and you should be able to see that the left, right, and the color sensors are correspondingly being defined for the particular mesh. So how can I go and actually look from the perspective of the camera? To do that, it should be straightforward. Uh, just go under cameras right here, and you'll be able to see all the cameras which have been created in your scene. You can now go and switch into the perspective of that camera, so that when you look at the scene, it's going to be through the lens of that particular camera. So as soon as I go here, I can see that this is what the Intel real sense camera is looking at the scene, and how you can see various parameters can also be set in the camera for fisheye lens and for shutter models and all related aspects. If you're interested, I would recommend you can go and look at uh, the various parameters which can be set and play around with it. So this the objective for doing this is actually wanting to make sure that if you also have a real world camera and you want to bring it into simulation, you want to find a corresponding mapping between the real world parameters to the simulated parameters, so that even distortion and all other parameters of your camera look the way they are in simulation. So that's very useful there. So we've also had that as a part of our release, and if you're interested in camera simulation in particular, I would recommend that you take a look at that too. Other things which have also happened is RTX LiDAR is now supported in Windows. Initially, it was only supported in Linux. So, for example, for running navigation samples with ROS, that's now possible in Windows as well. And camera calibration, like I just talked about that, that is something if you're interested in, you can look at. And other things which have also happened in the replicator realm of things were randomization and simulation, randomization for manipulators, and AMRs. So the best way to actually understand what might be happening there is actually just looking at the documentation, right? If I'm going to open up the replicator documentation, and here you'll see the samples I'm particularly talking about. So randomization and simulation for an AMR navigation use case, it's basically going to be ensuring that you're using Isaac Sim APIs to actually ensure physics plays the way it is, so you can move a robot around here and there. And you're also going to be using the replicator API, which is going to ensure that you can randomize particular aspects of your scene so that you can get a corresponding behavior. So in this example here, you can see in the images highlighted right here itself, the Carter robot, that is the mobile robot, which is being controlled by Isaac Sim APIs, and the position of objects in the scene, like the dolly plate right here, which is present, and it keeps moving around. That can be randomized to the replicator API. So that will allow you to do synthetic data generation on the fly while you're actually simulating your robot. And you can do something like this for manipulators as well. So in our talk today, we'll be focusing more on the raw side of things. I just wanted to give you an overview, but something you're interested in, you can certainly take a look at. The entire code is available with the release, and setting up the scene, setting up the randomizers, controlling the robot, doing all of good stuff there, that's certainly possible. And there've been changes on the Isaac Gym side as well for those of you who are interested in using reinforcement learning with Isaac Sim. Uh, Again, the best source for you to actually understand what's happening there is going to the documentation, and it'll guide you step by step in terms of the basics of how do you get started with that particular feature or extension, and then it will gradually build up towards advanced usage of that particular feature and extension. So I think the next main thing which I have planned for today is the raw side of things, where I'm going to be talking about how to use the new ROS bridge features which we have, which are a part of Isaac Sim. So, but before I do that, I'll quickly take a look at the questions and see if I can answer any of them right here. Okay, I'm working on a project. I can see the question on transferring simulations and movements of robots from Robot DK into NVIDIA Omniverse Isaac Sim. So sorry, I'm not familiar with Robot DK, but um, one way which, so are you looking to transfer only like commands which you send over from Robot DK into motion for the robot into Isaac Sim, or is that something else? It's not very clear. There existing tools or interfaces? Sure. So the best example for that would be actually the ROS interface, where you have the robot and all your software packages being defined on ROS, but the simulated robot actually being present in Isaac Sim. and we have a bridge which allows you to actually control various aspects of simulation through your own ROS written software. So that is one example of how you can actually control a robot which is simulated in IsaacSim through an external API or some through external libraries which are built independently of IsaacSim. And you can also write your own extensions with Python and C++. So, for example, if you're using any particular libraries and you want to control your robot or maybe have your robot perceive the environment in a certain way using those libraries, you can use the C++ or the Python extensions right there for doing something like that too. Which collision types interact well and which ones don't? We have SDF colliders that do not collide. Server. Okay, that's a very good question, Server. I think, but the best place for that would be the forums because I think that's a very physics specific question. In general, interaction between collision types is it really depends in terms of the joints and the meshes and the sort of things you're looking at over there because even in the rigging robots tutorial which I shown earlier right here, the setting up the colliders correctly is an important part for physics because that determines how the body actually interacts with how your robot or your rigged physics body interacts with the other aspects of simulation. So uh, answering that on the forums would be the best way for me to go ahead about that. You, okay, I think there are a lot of questions which have come up over here. Are there any plans to support ARM64 architecture in IsaacSim? Sorry, Sergey, as far as I know, not right now, but get back with the product team and see if there are any plans. But as far as I know, not right now. There are data interfaces such as Mujo CoF importer, URDF importer. Wondering these interfaces or any others can be utilized as well to import forward movements from Robotics into Omniverse. I think this is similar to the one which we just saw earlier, where the data interfaces are for getting the simulated robots into Omniverse. I can open up what robot DK is. I don't know what that is, but let me actually go ahead and do that otherwise. Okay, it's a library. So, okay, the answer to the question, Bolida, I'm sorry if I got the name wrong, but the answer to that question is yes, if they are libraries and if they're written like in Python or maybe C++, you can write corresponding extensions to actually bring them over into IsaacSim, and you should be able to use the APIs right then and there itself. We have a Kit extension C++ template example actually showcasing something like that in the ROS2 section for our samples right here. Let me go ahead and show that to you. Um, yes, so this is what that means where you can actually build your own custom C++ extension and add it into IsaacSim. So right now we've seen various extensions which are a part of IsaacSim like the URDF importer, the USD exporter, maybe the ROS bridges. But what if you want to write your own C++ code and have that packaged as a part of IsaacSim through an extension? So that is possible too. You can use the Kit extension C++ template. Let me paste the link of this particular thing in the chat right here. So this is the link I'm talking about for the Kit extension C++ template. What this will allow you to do is it will allow you to write your own C++ extensions, and then you can actually import these extensions into IsaacSim and use it with all the other components you might be making use of with ROS bridges or physics APIs and all that stuff. So this should be doable in general, and there is something which we will also be looking at for the ROS workflows in detail. So, okay, I think I'm going to take a pause for the questions for now and actually take a deeper dive into the ROS workflow, and I'll get back to the questions towards the end of our live stream. So, there are many changes which have happened for ROS in general right now. So, the first thing is that now we allow users to source their own workspace. So, what do I mean by that when we start up Sim? So, let me stop this simulation right here and open up the terminal again. Mm, yeah. So I'm going to source, so I'm on Ubuntu 22 and I'm going to source my Humble installation which I have on my system right here. So I've sourced it and now I'm going to start sim. So if you remember and if you've used Isaacson previously, we could not source our workspaces before starting up Isaacson because we were using a version of ROS which was compiled specifically for Isaacson. And if you try to source your own version of ROS, it causes conflicts between those two, and that's why the bridge does not load and you're not able to use it. But we've made changes to actually ensure that users can now source their own workspace so that all your custom messages, packages, and all that stuff can now directly be used with ISAC because those will be loaded at runtime from your sourced environment and it can be accessed through ISAC. And the ROS2 bridge is enabled by default. So if I'm going to go here and I'm going to look for ROS, my ROS2 bridge is already right here. And I can open up the terminal and see the log and it should yeah. So it's showing me that the bridge it started up successfully, and RCLPy, which is like the Python interface for ROS2, was also successfully loaded from the system level ROS2 installation. So this is what will happen when you can source your own workspace and start sim, and we're going to support this for Foxy as well as Humble. So let me open up the documentation right here and show you what that means. So we'll go to the installation section and we'll take a closer look at ROS. So for Ubuntu 22, we are recommending that you use Humble, and this is also a better approach in general because Ubuntu 22 is based off Python 3.10, and that is what is a part of Isaacson as well. So let me shut this down and show you what that means. So the default version which comes packaged with Ubuntu 22. So let me go ahead. So I can see that it's Python 3.10, and this is the version of Python IsaacSim is also using. So what this actually enables you to do is if you compile anything for ROS with Ubuntu 22 and Humble, what that will allow you to do is it will allow you to import those packages straight away into IsaacSim as well if you're using the Python API. If you're using C, C++ level APIs, then things will not change. But if you're using Python in particular, it's going to be easier for you to actually use Ubuntu 22 and Humble with IsaacSim because it's going to be very straightforward. But we also do support Foxy. So Ubuntu 20 based Foxy systems are also still supported. You'll be able to use the ROS2 bridge, the libraries which are used at runtime to actually enable the bridge and ensure that IsaacSim can communicate with ROS are already there. For RCLPy, the Python interface in particular, because Ubuntu 22, Ubuntu 20, sorry, is Python 3.7, you're going to see the issue of not being able to use RCLPy directly. So that's something which we've highlighted in our table right here. So Ubuntu 20 Foxy supports Python 3.7 by default. And what I mean by that is when you install ROS via apt-get, it's been pre-compiled with Python 3.7. So if I'm using a Python 3.10 interpreter and trying to use a Python 3.7 library, it won't allow me to do that. And that's why you won't be able to use RCLPy with with Foxy if you're in Ubuntu 20. But if you're in Humble, we are going to see right now, you'll be able to use it much more easily. But that doesn't mean that you cannot use the bridge itself. It's just that the RCLPy, the Python interface for ROS is something which you won't have access to. So in terms of support, we've got support for ROS to Foxy, Humble, and we're also supporting Humble on Windows. And you should be able to do all the tutorials which we have for ROS2 with Humble on Windows, and we've got instructions on how to install ROS2 on Humble, and it's a little different because you'll have to use the MS-IoT, the Microsoft supported version of installing ROS to Humble, and what that will allow you to do is it has all the navigation stuff which is needed for running the samples already pre-built. So it's more straightforward for you to actually use it directly with Windows that way. So the only thing for Ubuntu 22 is you install ROS directly from the instructions right here, where the official instructions will going to tell you on adding the repository, building the packages, and just installing Humble Desktop. The only other requirement for Isaac Sim in particular is a ROS2 package called Vision Messages, and you want to make sure that you also install that package for your corresponding ROS installation. And once this is installed, and you can source this and you can start up Sim. So now I think that's a lot of theory for now. Let me actually go back and show you what happens if you don't source ROS. So I'm going to open up a new terminal right here, and I'm not going to source my ROS installation, but I'm going to start up Isaac Sim. Let's see what happens. So let me go ahead and actually look if the ROS bridge did start up, and it looks like the bridge did not start up, the ROS2 bridge which we have. So let me go and see if the terminal did log something. So I can see a couple of errors right here. It's giving me an error, could not load the ROS2 bridge. Please make sure you have sourced your ROS2 workspace, or you need to set these environment variables. So what does this mean? So what this is trying to say is that if you do not source your ROS2 workspace and you start Isaac Sim, there is still a way to use the ROS2 bridge, but you need to set certain environment variables. Now, why is that? That is because Isaac Sim does it comes with its own level of compiled libraries for ROS. So let me go ahead and show you what that is. Um, so now I'm heading into the ROS2 bridge directory, which is under the Isaac Sim extensions, and we have the plugins for the bridges compiled. You don't need to worry about that, but you can see folders called Foxy and Humble right here. Let's see what's there. So these are the libs which I was talking about right here. So Isaac Sim also does come in with some the libraries which are needed for actually running ROS uh, as a part of the release itself, so that as soon as you actually install Isaac Sim, it is a part of Isaac Sim. But in order to actually use these libraries from the ROS side, you need to make sure that you set these environment variables. So so that your Isaac Sim instance can actually access all these libraries, and it can communicate with ROS. And if you do not do that, then you won't be able to load the bridge. So let me actually go ahead and quit this right here. And what I'm going to do is I'm just going to follow the instructions right here. It's saying in order to use the internal libraries included with the extension set. And I just showed you that these are the extension libraries corresponding to the ROS2 bridge for at least the Humble plugin, which we have. You need to set these environment variables up. So let's go ahead and set them up. So need to export RMW implementation is the middleware implementation for ROS2, and we need to set it as the default, which is fast RTPS. And the LD library path corresponds to the place where the dynamic libraries are loaded at runtime from. So we just need to add that path, and if you'll see right here, it's the same path which we have opened up right here on the left side. It's the Humble Lib path under the Omni Isaac ROS2 bridge, and this is also the Humble Lib path under the Isaac ROS2 bridge. So it's going to find these corresponding libraries when it's going to load the bridge. So let me go ahead and set that value to and start up ISACSIM. So let's see if our ROS bridge did start up this time. So we can see that it did get enabled this time. And let me look at the log right here. So yes, the bridge was able to start up successfully. And remember, I did not source my ROS2 installation because I have no ROS2 installation. As long as I've not sourced it in this particular terminal, ISACSIM does not know if there's a ROS2 installed on our system. Or for instance, any application does not know ROS2 exists until you source your installation. So we had no clue that there's ROS on the system, but because ISACSIM comes with its own pre-packaged set of ROS2 libraries for Humble as well as Foxy, what you can do is you can set those two corresponding environment variables up and you can run sim. And that will allow you to use the bridge, and the bridge will make use of the internal libraries which are a part of ISACSIM. And this is particularly important if you're planning to use Docker-based workflows where, for example, you might be having Isaac Sim running in one Docker and you might be having all your RAW stuff running from another Docker. You don't necessarily need to install ROS into the Isaac Sim Docker container. As long as you set the environment variables correctly before running Isaac Sim, it's going to use the pre-packaged version of ROS libraries and RCLPy, and it's going to load that. And you should be able to have ROS communicate between both those Dockers. And we do also have a section in an installation for ROS where it talks about how you can understand Docker container-based workflows better. So I'll recommend looking at that. But just to reiterate, it's even if you do not have ROS installed on your system, you can make use of the ROS2 bridge. You just need to make sure you set the environment variables correctly and the libraries will be loaded which are a part of ISACSIM. So that was one important aspect I wanted to cover right here. Let me actually go ahead and quit this right here. I'm going to shut down this terminal. Let's go back. We already had a Humble installation source, but I can source it again. That's not a problem. So let me source and I can start up ISACSIM. The next thing which I want to quickly go through is I'm just going to show a couple of OmniGraph nodes and how the ROS2 bridge works using action graphs on ISACSIM. Just a quick overview of that, and we'll understand how you can publish information from ISACSIM and subscribe to it as well in terms of OmniGraph nodes, and we'll try to understand what's happening behind the scenes there. So let me just make sure the ROS bridge is started up. It is started up. Let's create a simple action graph and let me scroll it up in case it is not visible. Okay, we have our action graph right here, and let's look for ROS nodes. So all these are the corresponding nodes which are available with the ROS2 bridge in ISACSIM. So we have a camera helper, we've got context nodes, we've got bounding box publishers, you can publish images, there are a lot of things which you can use in terms of uh, your robot actually sending information over from ISACSIM and actually receiving the information over from ISACSIM in the form of publishers and subscribers. So a most simple action graph would be just to publish maybe clock. So you can do that right here. I'm going to take a OmniGraph node called publish clock. It needs an exec in, so I'm going to use a playback tick right here. And I also want the simulation time. So I'm going to use this right here. So OmniGraph nodes basically allow you to set up action graphs so that you can have complicated behavior being executed depending on how you want various nodes to be interconnected and performing certain tasks. So over here, what we're going to do is it's going to be relatively simple. What this particular node is going to do, it's going to publish a timestamp in the clock message format over to ROS. So for reading the timestamp, I need to know the simulation time itself, and I'm going to be using the Isaac read simulation time. I'm going to go ahead and connect this to the timestamp input. So if you look closely over here, you can see that this is a timestamp and it's expecting data in the double format. So, and I'm going to read simulation time from this node, and I'm going to make sure that that is being passed to the publish clock node. And this node will only execute when the exec in condition is true, and that is going to be satisfied via this tick connection right here. On playback tick is basically when you hit play and physics rendering and everything has a time step and it actually walks through the simulation, and then that's when your simulator publishes or receives data. So we've set up our action graph. This is relatively very straightforward. It's just on play, publish the time and read the time from this particular node right here. So let's see if this is going to, so it didn't complain at all. It seems to be working. It's showing me that it's publishing this corresponding timestamp. Now let me go on the raw side and actually verify if that's happening as expected. Let me open up a new terminal and source my installation right here. As list. I can see clock showing up right here. And let me echo that corresponding value. So you can see that the seconds are correspondingly showing up on the raw side as well. I'm just publishing the clock from simulation, and I can see that on the raw side, I'm able to assert that the values are basically just the same. So this is a very simple sample of how you can use OmniGraph nodes, which have ROS publishers and subscribers with Isaac Sim. And you can also have more complex behavior being executed. So a sample for that maybe would be, let's create a new stage. If I want to publish an image, for example, that's something I would be interested in. So for publishing an image, I would first need a camera. Let me go ahead and create a camera right here. Camera right here. I've created a simple camera and create a shape. And I'm going to look at that corresponding shape through the camera. So it looks as expected. Now let me set up the action graph again. It's going to be a little different, but the structure is going to be more or less the same. Action graph and drag it right here. I'm going to look for a camera helper node. That's going to be our final node, which is going to publish to ROS. And we need a create render. Render product and playback. Oops, playback. Just these three nodes right here. So create render product is basically just going to take that particular camera which I'm going to assign it to. So you can see that it needs a camera frame. I'm going to take this particular camera which we just created, which is looking at the capsule right here, and assign it to this create render product. So all the render product information from that particular camera is now going to be streamed over to ROS using the camera helper node. We're going to set up that connection right now. So I've selected that camera. I'm going to make sure that the tick nodes are connected so that all the nodes are firing sequentially. And the render product path is something I need to connect right here. That's the only thing which is needed. All the other things are optional. You can for sure go ahead and change it if you want a different frame ID, for example. That's something you may be interested in. You can change that. You want different queue size. You want different types of topics you can publish bounding box information, depth information, PCL, segmentation masks, and all these types of ROS images in one sense, which you can have published over and change the topic names as well. I'm leaving everything right now to the default just to show how this workflow can actually be used. So we should be fine in not changing any of the values here. So let me go ahead and hit play. So didn't see any problems here. Let me actually see if uh, so I can see an RGB topic showing up right here. But let me see if I can actually visualize the same image. So I'll open up RViz and let's see if we can actually see the camera. Okay, so right here we can see that this is the view from that corresponding camera which we just set up. So let me go ahead and actually set it up right here. So this is what RViz is also showing you in terms of the camera looking at stuff. And if I'm going to move it around here, I can see that it's moving around in RViz as well. So what we've done here is simply that we've created a camera and made sure all the render product we've we've created a render product node and that's assigned to that particular camera, and all the information from that camera is now being streamed over to ROS through the ROS2 camera helper node. So that is basically how the camera helper would work. But if you're interested in looking at the other nodes, we've got a bunch of the other nodes for point clouds, for transform trees, and which are used for navigation, move it. And all of them work in similar ways where you would be connecting up various nodes from Isaac Sim to get data and actually pass it over to a ROS node, which is then going to send it over so that you can receive information from your own packages. And the other thing which you could also do is you could subscribe to join state, you can subscribe to twist messages, and yeah, that is how you can actually use the ROS bridge right here. So let me go ahead and close this stage for now. So this was a basic overview of how OmniGraph nodes are in IsaacSim. And one important thing right here, which I wanted to mention, is that it's not necessary you approach the entire workflow through GUI. You can also do it through standalone Python scripts. And we already have samples for doing something like that, where you can set up simulations such that you're starting Isaac Sim through Python, you're setting up the OmniGraph nodes, the action graphs, and the connections to Python, and you can manually step through simulation and do certain tasks. So all of this can also be scripted. It's up to you in terms of if you're getting started with IsaacSim, it's a little easier to actually use the GUI and understand how various nodes and graphs interact with one another. If you're a more advanced user and you're looking to scale up, it makes sense to script things because it's easier that way and you have more fine-grained control over parameters of the simulation as well as setup of your scene and other things. Um, I think the last thing which I was looking to cover was custom packages with ROS2 right now. So this is something which has been enabled because we now allow users to source their own workspace with IsaacSim. So it's going to be based off a tutorial which we already have. Let me open it right here. This is the C++ version of it. I'll be taking a quick look at the Python custom message package. Uh, sorry, workflow. So what we're going to be doing here is we're going to understand how we can use RCL based messages and how we can use the RCL based interface to actually use custom messages and packages with IsaacSim. So it is pretty straightforward to do. Let me go ahead and close simulation right here. We don't need this window too. That's okay. So we'll be following this message, this tutorial as is, and I'll quickly go through in terms of what we need to do. We need to first clone IsaacSim ROS workspace, and this is the link right. This one, sorry. Yep, this is the link right here. So IsaacSim ROS workspaces actually contains the sample Humble workspace and Foxy workspace, which are needed for tutorials which are a part of IsaacSim. So here is where we have our custom message package, and we'll be building this workspace. We'll then be trying to import this custom message into IsaacSim. So let's go ahead and do that. I'm going to clone it right here. So that is cloned. I'll go into the Humble workspace because I'm using Ubuntu 22 with Humble. And if I look at what is contained, it's just contains the source folder right now. So I need to build my workspace. I'll build it. Click on build. So it's building all the packages which are a part of our Humble workspace right here. Sorry about that. Three packages, standard error output. Oh, okay. Mm. Oh, it's these are not errors, they're just CMake warnings which have come through. I think we are probably going to be okay, but just to make sure that the packages actually got filled, let me source this workspace which we just created and see if I can list the packages. And we have a custom message package which we just saw, and let me see if that actually exists. Okay, so yes, I can see that the custom message package did get built, and so we should be good. So it's very straightforward of now using this with IsaacSim. Um, I've built the IsaacSim ROS workspace, which contains our custom message package with Ubuntu 22 and Humble, and I've sourced that corresponding uh, workspace which I just built. So let me start IsaacSim up again right here. So what we would expect here is that in the script editor or any Python script using IsaacSim, we should now be able to import that custom message directly. So just want to make sure that that is true. So one way to look at it is through the script editor. Let me actually go ahead and import our CL file. So that is the Python based ROS interface which we are going to be using. And let me see if I can import what I hope the name of the package was custom message, or was it custom messages? No, it's just custom message, so we should be good. Let me see if this runs. Okay, so this did run. I was able to import my custom message, but just to make sure that it's the right custom message which is being imported, I'm going to print it. So when I print a particular module which is being imported, it's just going to give me the location from where that module is being imported. Let me run that right here. Okay, is that a typo? There seems to be. Oh, trying to import it twice, I guess. Okay, now we're good. So it's showing me where the custom message module is being imported from. So I can see it's being imported from the IsaacSim ROS workspaces in our own Humble workspace, which we just built. And that is how I can ensure that messages which I've now built, as long as they're with Python 3.10 and Ubuntu 22, it is very straightforward to use them with IsaacSim and Python. But however, if you're using Ubuntu 20 and you want to understand how you can build your own packages and use them with IsaacSim, so let me take you back to the GitHub which we had right there, and that has all the instructions for using Ubuntu 20 based systems with Foxy and Humble, and actually building a workspace with Python 3.10 there. So let's open up a Ubuntu 20 Docker file, for example. So what's happening right here, the Docker file is basically just setting up Python to be Python 3.10 instead of Python 3.7 from Ubuntu 20 to, and once you've set up the correct Python version, the next thing what you need to do is you need to install ROS and make sure that while you're building ROS, Python 3.10 is the version of Python you're referencing while you build your whole installation. So we've set up Python 3.10 right here. Let me scroll a little bit to the top. You're installing Python 3.10 in the section. And then the important part here is we are installing a minimal ROS build, which is needed for actually enabling the IsaacSim bridge with Python 3.10. And once you've installed that, you're good to go. If you want your own packages built with Python 3.10, what you just need to do is you need to to go back here, and if you go in Humble Workspace, you can add your corresponding packages right here. And they will be pulled into the Docker file and built. So I'll recommend you look at the instructions for actually following along on 1 to 20, which are a part of our tutorials. You just need to build the Docker container which we provide in the GitHub and make sure that your workspace is added there. And once that's done, copy that folder out from your Docker container and source your installation and run isaacsim. So what that will allow you to do is now your packages and your workspace will be built with Python 3.10, and that will allow you to use isaacsim with the RCLPy interface for Ubuntu 20. So I hope that made sense. And this is something which we just saw that you should, once you've sourced your workspace, and it has the package built with the correct Python version, you should be able to import the message and you should be able to assign values to it. You can also create publishers, subscribers, and you can do all of those things as well. So I think this basically covered an overview of the topics which I had in mind for the raw side of things. There are many more things which we are planning to cover further down the line, but they should be good for now. What I'm going to do next is going to look at the questions and see which ones of them I can answer. So if you have any other questions, please post them into the chat too. So I think we saw a RoboDK based question right there. I can stop my sharing for now. Okay, that should be fine. We saw a RoboDK based question. I think you should be able to write your own C++ or Python extension, and you should be able to have those APIs being called with isaacsim. Mm. Two of the release notes for Gym extension, Tensorize soft body API, and RL example. RL examples with what, where are these examples located? Oh, okay. So for most of the release notes and the things which have sort of been added onto there, you should be able to find corresponding tutorials and documentation under the section for that particular feature. So for the Isaac Gym based samples, you should be able to find the corresponding information right in these tutorials. And if you still have any further questions, please reach out to us on the forums, and we can provide more information over there. What is the right approach to simulate an incremental wheel encoder, or at the very least, simulate a continuously integrating wheel angle, no wrap around 360 degrees? Okay, incremental wheel encoder. So I think there are ways to do that, but in terms of actually understanding what information you're needing from sim, uh, what what information would you be needing for the wheel encoder? Like, are you looking for ticks or are you looking for something else? Because if you, so for example, at least for the navigation samples which we have as a part of isaacsim, we usually have odometry being published directly from the wheels, and because we have the ground truth of the robot with reference to a particular transform, that is where we publish that corresponding information from an odometry, which then gets used by navigation. So for Servet's question on wheel encoder, I think the the first thing which you would need to identify is what sort of information do you need from isaacsim, and if that can be obtained through the physics API or through some sensor API, and then you could maybe publish it over to ROS or to whichever, or directly consume it from Python scripts itself. So it should be possible, but it depends on what information do you actually need in terms of the simulation for the wheel encoder for either physics, contact, or something else. So if you have an idea about that, I think the best way would be to correspondingly use those APIs and pull the information out. And if that is something which you want to look into further or understand better, I would suggest look at the physics APIs which we have too. You can also see questions for recommended workflow importing CAD models. I think this is something which we talked about earlier, but let me quickly show you what. This is a popular question of CAD. So CAD importer is something you can use right here, and so this will allow you to bring in CAD model files into Omniverse so that you have the corresponding USD representation. You can refer to the formats right here where these corresponding softwares can actually be used to create the CAD models. And the the only other thing once you're using these importers would be that you would need to set up physics in case of a robot. And you can refer to this tutorial right here in terms of how physics can be set up for a corresponding way to do certain things. So once you have your 3D CAD model imported into Isaac Sim, if you only need the visuals, maybe you're just doing some computer vision based task of where you just need the visuals of the object for training a model, and that's the only information. So you'll be okay. But if you're looking to simulate physics as well, you would want to make sure that you set up the joints and the hierarchies within your robot correctly so that physics behaves as expected. So using the CAD importer first and then following through on rigging up your robot, these two steps sequentially should help you get there. I hope I answered that question. Second, can we use that on Mac, USA Tech? So for right now, there's no, you can, if you have a remote workstation where you're running Omniverse on, then maybe you could use a Mac client to SSH into it and view that simulation, but there's no direct way of running Isaac Sim on Mac right now. Other ways include that if you are using maybe AWS or if you're using another cloud CSP based remote instance, then you can use like nice DCV, for example, Amazon AWS instances, AWS virtual workstations for Omniverse in particular allow you to use nice DCV, and a nice DCV client can be run maybe on Windows, Linux, or Mac, which will allow you to access that particular cloud instance directly and interact with simulation that way. But if you want to run natively on Mac, that's not possible right now. Do we have plans for radar sensor? Oh, we already have radar sensors right here. You you can set up ultrasonic sensors, physics sensors in a way that they're going to mimic radar. So it should be straightforward. Even for let me look into the documentation quickly. So we have LiDAR right here. Uh, okay. Okay, but it should be straightforward to simulate a radar as well with the physics APIs which we have. Ultrasonic sensors can be used to mimic radars in a particular sense. Uh, so that should be helpful at least for getting started. But if there's a particular simulation you're looking for and you think that is not available, please open up an issue on forums as well, and maybe we can help you there further. Think, yep, someone's already answered that. The radar's already there. Any plans? Does the real sense return 3D point cloud? So yes, this is something you can do. So once you have set up cameras in a certain way, for example, let me go ahead and set up the Intel real sense right here. The real sense is right here, and the real sense has corresponding cameras attached inside of it, the simulated cameras. So we have a pseudo depth and we have three other cameras corresponding to left, right, and color. So what you can do, for example, if you want to uh, publish the point cloud information from there, when I'll be creating my action graph, so let me create an action graph right here, and I'm going to use the ROS2 camera helper node itself, but the camera which I'm going to be using right here. So the render product needs a camera prim. what I'm going to do is I'm going to select a corresponding camera prim from the real sense itself. So I can select the depth, pseudo depth, or either of these color cameras, and that is what is going to be used for publishing information over to ROS. So that is, I selected my render product for the real sense camera, and in the camera helper, I can specify I want to publish depth or depth point cloud, depth PCA, either is fine. And once I've done that, I'm going to be technically getting the depth information from the corresponding camera prim within the real sense, and that will be published over to ROS. So that is how you can get 3D point clouds being returned from the Intel real sense, or for example, any other camera in ISXM. As long as you create a camera, specify the right parameters, you can then hook it up to ROS, get its render product, and publish over the 3D point cloud corresponding to that camera. So I hope that answered the overview of a question in terms of getting and creating camera prims and making sure that the parameters are set up correctly so that you can publish it over to ROS. Warehouse Builder is quite difficult to use. Is there any video for how to use? Should be a part of the tutorials for warehouse logistics that we, if you have particular use cases which seem to be difficult to replicate in sense from the tutorials, then feedback would be great for actually improving and adding more documentation over there. But we do have step-by-step guides in terms of how you need to add particular assets from the warehouse conveyor belt or other things which would be needed for building uh, the whole warehouse which you're looking for. So uh, like we also do have corresponding GIFs added into the documentation. So if there's anything other than this you're looking for, or if you're stuck and you find maybe a bug in the documentation, please let us know. Is the physics for the Carter robot bug fixed? The caster joint used to break when we add in between the caster, add weight. Oh, Nilesh, that's a good question. Do is as far as I know, the newer Carter asset is the Nova Carter asset, which is used for the navigation samples and all the other ROS2 samples in particular. Let me open up that navigation sample quickly right here. So we're making use of the newer Carter Nova asset right here, the robot which you can see in this corner. So, but I can understand that your question is related to the previous Carter. We'll have to check that and get back to you. Sorry about that. Does Jim run on Windows or is it only Linux? That's a good question. I don't think I can see any Linux specific uh, things on Gem. So you should be able, yeah, there is also for Windows. So you should be able to run Gem on Windows as well. Like we've got instructions for a Linux, Windows, and Docker containers. So you should be fine. Are there any ways to work with URDF and CAD models without having to maintain it separately? That again is a good question, Servet. For URDF and CAD models without, I think it also depends in terms of are you using the URDF importer with ISXM to actually get your robot in, or are you using the CAD importer? Because then using both of them separately would cause the issues in the first place. If your workflow is that you're going to have the CAD model, which is then converted to URDF, and that is used with ISXM, it should be straightforward. You should not be having to worry about maintaining version control for CAD as well as URDF. But if you're using maybe visuals and meshes from CAD in some sense, and I don't know, some sort of physics definitions being added from URDF, and it's a mix and match of those two, that would lead to problems. So I think a good way to go about it, if possible, would be to use the URDF importer directly and make changes only to the corresponding URDF so that it's easier to get into Isaac Sim, and physics and stuff does not change. Because with changes on the CAD side, even minor changes where you're moving around hierarchies and stuff like that and getting it into Isaac Sim, I think rigging physics and doing all those steps will take up more time as well. So might make more sense to stick with only one workflow over there. And if you can specify why there is a need to actually switch between both of those workflows, maybe open up an issue on the forums, we should be able to give you more guidance there. I can see a question for ROS2 custom node tutorial C++ only available for Linux. When will it be available for Windows? Uh, that's a good question. For Windows, uh, we do not have official support yet, but it might actually work directly as is, because the libraries and the dependencies of the ROS2 bridge are also present on Windows. You can try compiling it, and if you run into issues, then you can open up a forum post and maybe we'll be able to help you out. Okay. Thank you, Servet. I think, yeah, you've got a lot of good questions, and if you can post them maybe on the forums, or maybe I'll take note of them so that we can get back to you on terms of the questions which I was not able to respond to. Oh, I think you've got a lot more questions specific to meshes, CAD models, and stuff like that. Uh, Let me get back to you for those. And if you already have a forum post for those corresponding questions, it would be great if you can add it into the chat as well. Real-time factor performance is close to. What do you mean by validating real-time factor? Like, are you trying to make sure that so you do have the FPS running for your particular scene with all the robots and all the sensors and all that stuff being simulated? In terms of real-time factor being validated, that the initial measure could be that you just measure what the FPS is versus compare it to 60 frames per second or 30 frames per second, and you can have a rough approximation of the number from there. Or you could also do it from the raw side. Oh, I can see Leela's answered a lot of questions. So thank you, Leela. Okay, I think Leela did answer a lot of questions, so that seems to have cleared up many of Servet's questions in particular. And I can see a couple of questions down there about ROS navigation. ROS navigation be run on any environment other than what it launches with a simple warehouse? Yes, you can run ROS navigation with a couple of other environments too. Let me open up uh, the documentation right here. I think the documentation is the best place to find the answer to that question. In our documentation for the ROS2 navigation tutorials, we also have a multi-robot navigation tutorial. So what What multi-robot allows you to do is we already have occupancy maps generated for two other environments, which are the office and the hospital environments, which have their versions represented like this. So in the launch file itself, let me open up the launch file now. Just a second, let me find the Isaacson folder. Look, here we go. Okay, so in the Isaac Sim ROS workspaces folder right here, if you look in the Humble workspace and you look at navigation, for example, in the Carter navigation, we've got three maps right here. And what you can do in the launch file is you can specify the different maps which you would need. So we've got multi-robot, which if you are interested in multi-robot, you can take a look at that. But if you're looking at individual launch, all the files which are loaded at a runtime when you actually launch your navigation can be set up, and the default is the warehouse navigation, and that's why that's the scene which gets loaded up. You can change it up to a file of your choice, and you should be good to run it. So I hope that answered your question. Question out of curiosity: document controlling a robot with URDF. It's Turtlebot. Nova Carter is used. Was there a special reason? Oh, that's something which you should be able to do for any of the robots, because for the Carter robot collection, we've set up the whole action graphs so that you can actually publish to and subscribe to all the relevant topics for navigation. That makes it easier to use it directly. You should be able to do it with the Turtlebot also. Once you've got the articulation controller and the subscribe twist set up for Turtlebot, that's the first step to tally up the Turtlebot. But if you actually want to set up navigation with it, then you need to set up the LiDAR on top of the Turtlebot, and you need to publish all the transforms. And for doing that, what you can do is you can use the Carter robot, the Ross Carter robot, as a reference asset and set up the Turtlebot action graph in the corresponding way. And you should be able to run navigation with the Turtlebot too. So I hope I was able to answer that question. Thank you so much, Servet. Appreciate you saying that. Yeah, it would be great. I think you've got a lot of good questions. If you could open up a post on the forums where you summarize all of them, that would be great. We'll have someone take a look at it internally as well and help you out. But I hope I could answer all of your questions today. Uh, I think that's about it. There's no other questions which I think we covered most of them, and for some of them, if I was not able to answer it, or if you think that we missed out on something in particular, please reach out to us on the forums. We'll try our best to help you out. Thank you so much for joining us, and stay tuned.